This lesson is for Advanced Algebra, Lesson 1-2, Relations and Functions. We're going to start by really quickly talking about relations. Relations are any set of ordered pairs. So there are many things that can be considered relations. The one that we're going to focus on today is a function. A function is a type of relation. A function is when you pair an independent variable with a dependent variable. Within that pairing, each x has to correspond to exactly one y. Typically, your x variable is referred to as the independent, and your y is referred to as the dependent. We'll look at some examples today where x and y are not used, and do that to try to help kids understand which one is the independent and which one is the dependent when x and y are not used. Typically, the book will ask you the question, is y a function of x? And the way that I have kids handle that is to replace the word function with depend. Does y depend on x? And then to answer that question, you'd want to remember the definition of function. Is each x paired with only one or a unique y value? We'll look at some examples today to help us be able to answer that question. Another thing that I want students to think about when it comes to understanding what a function is to think about it like a machine. My crude drawing here of a machine hopefully illustrates it. You could also think about a vending machine or a copy machine. The original or independent or x value is what goes in to the machine. So independent goes in. Something happens to that variable along the way, so there are changes made to x, or operations happen to x within the machine, and then a result is spit out, the dependent variable or the y. So think about using a vending machine. You'd plug money in, magically inside the machine it turns the money into a can of pop. The biggest thing that students need to remember is simply that x or independent goes in, y or dependent comes out. And so students can draw whatever picture helps them remember that the best. Let's next look at independent and dependent variables as it relates to equations, ordered pairs, and tables. If we're working with just a basic equation, it's pretty clear to see that the x and the y variables are there. And so most students are comfortable with the x being the independent variable and the y being the dependent. I'm using abbreviations here just for time's sake. The problem comes in when letters other than x and y are used. So let's rewrite the problem as m equals 3t plus 12. In this case, if you're not sure which variable is which, think about it again like a machine. You'd start with the letter t, things will happen mathematically, and then it spits out the outcome of m. So you'd still have your independent variable as your t, and your outcome being the dependent variable, or in this case, the m. Another way to think about it in that case, the variable that's isolated is the dependent variable. When you're working with an ordered pair, most students are comfortable labeling the ordered pair as the first number being x and the second number being y. So when you're working with an ordered pair, even if the letters have changed, the first number is the independent one and the second number is the dependent one. In a table of values, again, if x and y are given, then it makes it real simple to remember that independent is y, dependent is x. If other letters are used besides those, a good rule of thumb is to think about the x values or the independent variables being on the top row and the dependent variables being the bottom row. If your table ends up being vertical, typically the first column is the independent and the second column is the dependent. Let's put this more into action now with a few examples. Here we have 4 tables, and in all 4 tables the x values are 1, 2, 3, 4, with the exception of the last example that goes 1, 2, 3, 2. Now let's look at the y values in each table. We got 1, 2, 3, 4 in the first, 2, 4, 6, 8 in the second, 5, 5, 6, 7, so we have a repeat here in C, and 4, 5, 6, 7 for the last example. What you want to do with each of these is visualize that function machine and say to yourself, if I plug in 1 into the machine, and if it spits out a 1, is that okay? We would do that for each value within the chart. So 1 results in a 1, a 2 results in a 2, a 3 results in a 3, and so on. So is that a function of y? Another way to ask it, is y depending on x? And so we would say yes here. Each x is paired with a unique y. How about on example B? You plug in a 1, you get a 2. Plug in a 2, you get a 4. Plug in a 3, you get a 6. Plug in a 4, you get an 8. All of those values are clearly unique as each other, or unique from each other, so we would say yes. Y is a function of x for example B. Now examples C and D I would kind of like to do together because we have repeats in both cases. Here we have a repeat in the y value, and on D we have a repeat in the x value. Only one of those repeats is allowed as it relates to function wording. So let's look at example C. If you plug in a 1, you get a 5. You plug in a totally different x of 2 and you still get a 5, that is okay. So as long as the x's are independent from each other, it doesn't matter that the y's are repeating. So we'd say here that the repeats in the y are allowed. And they'd only be allowed for different x's. Now let's look at that same idea of a repeat, but this time in the x value. Again, if you think about it like a machine, you plug a 1 into the machine and it spits out a 4. You plug a 2 into the machine, it spits out a 5. Plug a 3 into the machine, it spits out a 6. So far, we're okay with this being a function. Now we're going to revisit plugging in a 2, and according to our table so far, the 2 should result in a 5. In this table it doesn't, so we're going to say no, this is not a function. And let's go back and finish C here. We forgot to say yes, this is a function. So in these 4 examples, we've got 3 yeses and 1 no, illustrating that if all the x's are independent from each other, it is a function. If the x's repeat and give a different value, then it is not a function. One of the things that I have students do in class is consider changing this last example to turn it into a yes. Typically what students come up with is changing the table so that the x's stay the same, and then we modify the y's to turn it into a yes. So we could do 4, 5, 6, and then when we revisit the 2, as long as that still spits out a 5, now it could be considered a yes. There's other options here for how you could modify the table. You could also modify the 2 and turn that into a 4, and now that would turn into a yes. We have one more example I'd like students to look at. This is more like what you'll see on tests and quizzes. They give you a table and they ask you, is y a function of x? So this question is very similar to the ones we just did above. Is y a function of x? Let's look at all the values and see if all the x values are independently paired with the unique y value. And as I look across here, all the x's are different. We do have some repeats in the y, but I do remember from our previous examples that any repeats in the y are allowed. So on this first one I would say yes. Y is a function of x. The second example, or the second portion of the question, asks you to reverse the process. Now they want to know, is x a function of y? Personally, for me, it's hard for me to visualize that table if it were upside down. So I usually tell students, go ahead and flip it so that your independent variable would be on the top and your dependent on the bottom. So I'm just going to take those values and turn them upside down. So I've got y on top now and x on the bottom. So on the top I'm going to have 5, 7, 4, 4, -6, and 7. And on the bottom, 0 to 5. So now as I look at that table, I remember that the top row, or the independent variable now, has to be unique. I do notice that there is a repeat there, and I'm just going to verify if the y values are the same. When you plug a 4 into the machine, it spits out a 2. When you plug a 4 in again, you get a different result. So here I would say no. Later on in the chapter, we will be learning how to visually tell if something is a function or not. For this lesson, our focus was on finding functions from tables.